Greeting to all. Today I am going to take a class in chemistry. Before revealing the name of the chapter, there is a picture which is placed on your screen. What do you observe? A magnesium ribbon is burnt and magnesium oxide is collected. Magnesium ribbon is burned and magnesium oxide is collected. So magnesium ribbon is converted into magnesium oxide. So there is a complete transformation going on from one form to the other form. This transformation is called as chemical reaction. This transformation is called as chemical reaction. So the name of the chapter which I am going to deal right now is chemical reactions and equations. An activity is seen on the screen in this point. Why we should rub the magnesium ribbon with sandpaper. Why? It is done because in order to remove a layer which is protecting magnesium from burning. This layer is magnesium carbonate. Let's look at a video.
Demonstration of a chemical reaction, that is burning of magnesium. So here I have a strip of magnesium which is cut from the magnesium ribbon. So this is the magnesium ribbon and this is Bunsen's burner and a watch glass in which I am going to collect the magnesium oxide, which is white in color. These are the pair of tongs. So when magnesium reacts with oxygen, it requires heat energy, and after initiating this reaction, you will see that the magnesium burns in presence of oxygen to form magnesium oxide, and magnesium burns in oxygen with a brilliant white flame, that is called a dazzling white flame. Very difficult to see that. So let's try the experiment, and here I am going to hold this magnesium ribbon. Actually, we don't require a very big piece of magnesium. It's very handy. You can even break it with your own hands. So I choose to put all other things aside. As you can see that magnesium burns with a dazzling white flame.
How do we identify a chemical reaction? So, by the following observations. What are the following observations? Number 1, change in state. Change in state. Number 2, change in color. Number 3, evolution of a gas. Number 4, change in temperature. Now we are going to discuss in detail about the following observations. Change in state. Change in state is physical process. Is physical process. Let's take an example of conversion of solid to liquid and liquid to gas. Solid is converted to liquid by melting process. Solid is converted to liquid by melting process, whereas liquid is converted to gas by evaporation process, and gas is converted to solid by deposition process. Similarly, gas has been condensed. Gas has been condensed to form liquid, and liquid on freezing turns solid, and solid on sublimation turns gas. So this is the entire physical state of matter. The next observation which we are going to learn is change in color. Change in color. Change in color. The best example I can give you is copper sulfate. Best example I can give you is copper sulfate, SO4.5H2O. Copper sulfate. Basically, the color of copper sulfate is blue. The color of copper sulfate is blue in color. But when you heat it, then the copper color, blue color, will be converted to white. The blue color is being converted to white. This turns white. So let's see an example. To identify a chemical reaction is evolution of gas. The example is when zinc reacts with hydrochloric acid, we get zinc chloride plus hydrogen gas is evolved. Hydrogen gas is evolved. This evolution of hydrogen gas is recognized by this evolution of hydrogen gas is recognized when you get a pop sound. You get a pop sound. You get a pop sound. And when you get a pop sound, when you introduce a burning splinter, a burning matchstick. Let us look at a video.
Now I have the zinc in this Erlenmeyer flask, and all I need to do is to pour this hydrochloric acid in. So you might be wondering, how much of this hydrochloric acid do I need to put in? I would say about 40 to 50 milliliters. You just have to pour enough to have a reaction to produce that hydrogen gas from the single displacement reaction. So I'm just going to pour about here, and once I finish pouring, this is going to start bubbling because that's going to be our reaction. And I'm going to shake it a little bit, put my inverted funnel into my test tube, and keep shaking. And you can see that there is a lot of bubbles being produced. So I'm just going to let this reaction occur for a couple minutes just to get enough hydrogen gas into this test tube. So right now what's happening is that in single displacement reaction, the hydrogen gas is actually being produced, and it's going to go in and store in this test tube. Why it's storing in this test tube again is that because hydrogen gas is actually lighter than air, so it's not going to sink down. So it's going to be around here, it's not going to flow up because this test tube is going to capture it, and now we're just going to have to wait, and to test the hydrogen gas, we're going to light a splint, and since hydrogen gas is flammable, when we put it in, a lit splint into the test tube, we should hear a popping noise. Or after a couple minutes, you can see that the hydrogen gas is collected in a test tube. The test tube is a little bit cloudy, so we have to kind of light this on fire to test if there's hydrogen gas in the test tube. So here's my flame. I'm going to put it in. Oh, so we can hear that little high pitch, and that's the presence of hydrogen gas being burnt inside this test tube.